In this chapter, we're going to talk about transformations, but more specifically, we're going to talk about translations in this section. So there's many different types of transformations. So we'll go through a few of those first off. What is a transformation, though? A transformation is an operation that moves an object, a pre-image, to a new location called an image. There are 4 specific types of transformations that we're going to discuss throughout this chapter. The first one is called a translation. The next one is a rotation. Then there's a reflection, and there's a dilation. So a translation can also be referred to as a slide. It will move every point on the object in the same direction and the exact same distance. So think of just picking up an object and moving it to a new location. It's the exact same shape. All it's doing is just sliding it to a new spot. So some things that you need to consider when you're doing translations is, what direction are you moving the shape? So am I moving it up, down, left, right? How many units did I actually specifically move it? So if we take that object and we now put it on the coordinate plane, how many units did I move it left or right? How many units did I move it up or down? And then there's 3 ways that we're going to focus on how to write these rules. The first one is basically just putting it into words. I move it left or right, and then I move it up or down. Now, the reason we say left or right and then up or down is because it's just like having your x-axis and then your y-axis, having x comma y. So left or right would be your x-axis, up or down would be your y-axis. You can translate that to either algebraic notation or coordinate notation. The algebraic notation or coordinate notation is when you specifically identify how much you are adding or subtracting to your x, how much you are adding or subtracting to your y. Or the shorthand way would be vector form. Vector form is when you use a less than or greater than symbol and you just take the numbers and you put those into your vector form to show exactly how much is the x, exactly how much is the y. So write the rule. If we take a look at these 2 shapes, the first thing I'm going to do is identify my pre-image, and then I'm going to identify my image. Now, the reason I know this is my pre-image and this one is my image, because take a look at the labeling. This triangle down here is labeled ABC. This triangle up here is labeled A prime, B prime, C prime. That apostrophe is known as prime notation. So your pre-image is going to be labeled with just your regular letters, and then your image, after you do your transformation, is going to be labeled with prime notation, or with the apostrophes. So write the rule. I'm going to first do it in words. So in terms of words, left or right, we're going to take this pre-image and we're going to move it to the left. So that would be subtracting, but we are going to move it left 1, 2, 3 units, and then we're going to move it up 1, 2, 3, 4 units. So if I take this would be your wording, left 3 units, up 4 units. Now if I take that wording and I translate it specifically into an algebraic function, so my values, each one of my x's and each one of my y's, I'm going to translate them by subtracting 3 to my x, and I am going to add 4 to my y. So this would be your algebraic notation or coordinate notation. So it specifically shows you your x's and your y's, what you are doing to each one of them. So if I took, for example, this coordinate, that specific coordinate, I could subtract 3 from the x, I could add 4 to the y, and I would end up with this coordinate. So from my pre-image to my image. And then the last one, the vector notation. So the vector notation just takes the values and shows you that you're going to subtract 3 on your x's and you're going to add 4 to your y's. Again, it's just a shorthand way of showing your values. The rule here, if we want to use words first, so again, we're moving this left. We're moving it left 1, 2, 3, 4, 5, 6, 7, 8 units. Left 8, and then we are moving it up 1, 2. If we translate that to the algebraic notation or the coordinate notation, we're taking our x's and our y's, we're taking each coordinate and we are translating them, that's what that arrow is, we're translating them by using the equation where we are subtracting 8 on each one of the x values, and we are adding 2 to each one of the y values. And then vector notation, just take the values. So -8, comma, 2. So what does each one of these rules mean? Each one of these rules is your algebraic or coordinate notation. And this first one is telling you to take each coordinate and you're going to add 1 to the x, add 4 to the y. So if I took the coordinate, for example, I could take this corner right down here on the bottom left. That corner is 2, 0. This algebraic notation, this algebraic translation, is telling me to add 1 to the x, add 1 to the x and add 4 to the y. So from the pre-image to the image, 1, 2, 3, 1, 2, 3, 4, this is how it would translate. So from the pre-image to the image. We can do that with the other coordinate if we wanted to. So you don't have to specifically take the object and translate it. You can just translate the coordinates first and then plot them and then draw your shape. So I'll do that. I'll do the same thing with this one down here on the bottom right. So that coordinate is 6, 0. And the translation is telling me to add 1 to my x, add 4 to my y, and plot my point. And then this coordinate up here at the top is 4, 7. And that one, if I translated it using this algebraic translation, we would have 5, 11. So that one would be plotted way up here. So your image, ooh, that was bad. From your pre-image to your image, you can see the translation of to the right 1 and up 4. The next rule, so this one's telling you to take each coordinate or take the entire shape and move it to the left 2 units and move it down 2 units. Our next one here is telling us to take the shape and move it to the left 5 units and move it up 6 units. And then the last one, if we just change that to words, it's telling us to take your shape or your coordinates and move them to the right 3 units and move them down 5 units. Apply the rule. So here we're taking and applying the rule to our image, but we're also going to reverse the rule and apply it to our pre-image. So this first one, what is the image of? So they're telling us that this here is our pre-image. And the pre-image and image, that connotation gets a little confusing. So it's going to take some practice to get used to what is the pre-image and what is the image. So the pre-image is the original. So this is our original. They're telling us that it's plotted at -3, 4. And then the rule is telling us to move it to the right 4 units and move it down 6 units. So if I just apply the rule, all I really need to do is just take -3 and add 4 to it, and then take 4 and subtract 6. So from the pre-image to the image, we end up over here, right down there. And that would be to the right 1, 2, 3, 4, and down 6. 1, 2, 3, 4, 5, 6. Now, what is the pre-image of 0, 4? So they're telling us that this is the image. So in other words, it's what we get after we move it. Pre-image is your original. The image is what we get after we move it. So after I take my x value and I add 4 to it, I need to come up with 0. So what x value, when I add 4 to it, is going to give me 0? Well, that means that x had to have been -4. And then this 4, well, that's what I get after I move it. So when I take my y and I move it 6 units down, I need to come up with 4. So what y value, when I move it down 6, gives me a positive 4. And that would be add 6 to both sides, and we get 10. So your pre-image would be -4, 10. So the original would be plotted way up here, and then after you perform this translation, you should end up with 0, 4. Right there. So let's double check to make sure that works out. So this is the original, and then we would move it to the right 4, 1, 2, 3, 4, and down 6. 1, 2, 3, 4, 5, 6, and we end up at the image. Again, this one was just backwards. It's just kind of reversing the rule, trying to get you to think about it in both directions, forwards and back. Using vector form. So write the vector or component form for each slide. So here's our vector. Vectors typically, or actually vectors always have like a starting point, and then they have their array to show you a direction. Technically a vector is both size and magnitude, but for us, our vectors are simply going to show us a translation direction and distance. So this CD is our vector. Now vectors are labeled with just a partial ray. So CD, it's labeled with a partial ray in its direction. So D is the direction. That's why my partial arrow is on that side. Over here, P, let's label this down here. I'm going to put another point down here and label it M. So this one over here would be labeled P and then M, and then our partial arrow in the direction of the M. So write the vector in component form for each slide. So from the starting point in this direction to this point here, where it ends technically, we would go to the right 1, 2, 3, 4, and up 1, 2, 3. So to the right 4, up 3. That's how you would write it in vector notation. For the second one over here, from this point to the end point of the arrow, the tip of the arrow, for this one we go to the left 1, 2, 3, and down 1, 2, 3, 4. Slide the triangle. So ABC is translated on a graph using 4, 2. So this 4, 2 is telling me to the right 4, up 2. Now if I wanted to, I could plot these 3 points, or I can just go ahead and use the algebraic notation. So this is telling me to add 4 to my x, add 2 to my y. So I can go ahead and use that algebraic notation to come up with my coordinates and then not have to plot it and translate it. So after I translate 4, 5, 6, 7, -1 and a +2 would give me a 1. This next one would be 5, 3, and then the last one would be 7, 7. All right, now we can plot the pre-image if we wanted to. So we can plot the pre-image. We can plot the image, and then we can take a look to make sure that it went to the right 4, up 2. ABC is translated on a graph using 4, 2. Slide the triangle. I'm just going to plot out the second one. So 7, 1, 5, 3, and 7, 7. I suppose I could plot out the pre-image also. I'll just plot out the pre-one as well. 3, -1, 1, 1, and 3, 5. There we go. All right, so in this section, we focused on the initial transformations, and then we specifically focused on translation. So with our translations, we took a look at the vector notation, the algebraic or coordinate notation, and then we also took a look at how it would be written